All right, welcome everybody to Cloud Native London. We're now live streaming on YouTube, so please feel free to chill out. We've got about 15 minutes before we kick off a reel. In fact, I was just having a really good conversation with Hubert about how he was onboarding new people during the middle of coronavirus and giving people access to code or whatever. So I'd love to ask if anybody else has thoughts about how they, or any recommendations about how they onboard new people. Also, you have to listen to my choice of music for the next 15 minutes. So I hope you like lo-fi. I hope you like pretending that we have pizza. One day we'll go back to live meetups. People feeling a bit shy. Somebody else has how people onboarded like new people to their companies. All right, I guess nobody has any other thoughts. So Hubert, it's back to you and me.
It's more a question if someone is involved in onboarding of the new people. You know what I mean? So I managed to become who I am, but so I have to be involved to be sure that we can follow the standards. But if you if you are responsible for uptime for code, like or you are a developer, you're a little bit less worrying about this stuff. So maybe also I have someone on the chat.
I'm just trying to get people the links. Cool.
So
basically, it's not easy.
It's not easy, and again, was really kind of interesting because it was overwhelming in terms of people what they actually have to been unfortunate to say goodbye, and it was actually quite a lot of good candidates. However, the challenge, the biggest challenge was, and I'm really surprised to say this, that we have a very strong kind of old-fashioned sysadmins, all the developers, all very, very baked into like a one cloud provider. The people so they said, "Oh, we love Kubernetes. I know everything about this one specific thing from this one cloud provider because they hosting Kubernetes." So asking him,
really?
So I will use here, for example, is Google Engine have a Google Cloud, of course. So there people come with a certification. I have a certification from Microsoft Kubernetes. I have a certification for AWS. But if you start to peel what they know only about this one cloud provider, it starts to shows up. They don't understand how the Kubernetes really works. So when I start to asking, okay, so what's the network? So if there is AWS, what did you use, for example, with the networking? So to basically to make the network works. Oh, he said, the flannel. But I know that now Cailliau is. So did you use Cailliau? No. So how Cailliau works? So it's different. So I think that there was something what will have to be a little bit more. Again, I hope that they find the good employer, because again, outstanding smart people, just they are not fitting perfectly to what we've been looking for. And as a Suade Labs, which you have a little bit different challenges than but most of the talks what I ever heard for the CNCF. So I hope that I will be able to provide today. So a little bit different view, a different approach to awesomeness of the Kubernetes world, and yeah.
Awesome. I'm going to apologize for a second because someone's just told me that the YouTube live stream isn't working. So give me a moment. I'm going to fix this. Might have to kick people out, but let me try and fix this first without doing that. Oh, wow. Okay. Excuse me. I'm going to pause the music for a second as well.
It's live.
Oh, your one was saying it was okay?
I just went to the website, so let me. Yes, it works.
It's all good?
Yeah.
Okay.
I'm just finding that it's a little. There's like a 1, 2, 3, 4, like a 10 of us on the. But okay.
Okay. Okay. If it works, cool, awesome. We'll go back and do another sort of 5 minutes of. Let's get to the end of this lo-fi track because I haven't heard the ending. Okay. Yeah, there's about a 5-second delay between Zoom and YouTube. Yeah, I'm wondering. I hear really good things about Cailliau, but I don't know enough about it.
I know Cailliau since OpenStack. Hey, in that long, they provide a network for OpenStack. Back in the day, now they completely focus on the Kubernetes. The whole idea is that they use BGP. So I always forget the order gate protocol for exchange information. So, for example, Wikipedia, when they start embracing Kubernetes because they have their own data center, they use BGP. They use Cailliau, so they can expose the BGP to not from the virtual machines, but straight away to the network switches. So if the whole master, the old nodes was down, the BGP was still in the switches, so they can still serve the network to the containers. Pretty cool thing. Also, it's faster, and one of the biggest point, what I think it's more worth noting, they use the security engine not only from the Kubernetes. So if you think that software, it is like a pre-Istio security for the network. So it is really awesome that you can have this policy with the labels defining that this container can connect with this container from these labels. So I find, for example, the awesomeness of this solution is that you can have this policy enforced on the level 4, like a databases, and Istio, it is really heavy focus to be compliant with the Envoy, which is really good for the layer 7 for HTTP. A little bit and he lacking a little bit with the level 4. And for example, if you use Postgres, you find that it is actually quite challenging how to secure it. And the Cailliau is really solved this problem from beginning, from the network perspective. So really awesome tool. And challenging a little bit more than Flannel. But I really adore Cailliau. So at the point where I was using, I was really happy.
So you're not using it now?
No, I do not use now. This will because the journey what we've been have with the Kubernetes, and this will be. So I don't want to spoil too much. This will be in my talk.
Okay.
This will be there. So stay tuned if you want some more.
Yeah, we'll wait. going to ask how much longer do we have, but I managed to kill the end of it. So, okay, let me try this again. This is one of the bad things about using YouTube link as opposed to OBS. I think with OBS, I would have better control over the audio and the tracks separately.
Yes, so I agree. That was one of these things when I think every single company embraced this, that you have like a daily stand-up in the morning, that you gather the team and everybody was saying what they're doing. But what awesome our boss did is fantastic. And so what she decided that every single Friday we sit down, we'll have something to drink. So every Friday we sit down and have half an hour chat to back out to feel that we are not locked at home and there is more people to talk with. And that was one of these things what I found it that Zoom is really good. And my train file just disappeared. But YouTube link. Okay. End of the music. So
officially we should be starting the meetup now. Okay. Some people were saying that the audio for the music was a bit loud and covered up the conversation, for which I'm sorry. This was an experiment to see if playing music at the beginning of the meetup would be fun. So I think people like the music, right? Like give me a reaction thumbs up or whatever. Tell me if you think the music is a good idea. Next time I'll just try and find a way to make it a bit quieter so we have the conversation as well. Okay, people thumbs upping. So I'll try for next time, try and make the audio a bit quieter on the music, but awesome. Okay, let's kick off. So welcome, this is the Cloud Native London Meetup Group, and we are a strong, open, diverse developer community around the cloud native platform and technologies. Typically in London, right now we're virtual as everybody else. So thank you everybody for joining. I'm Cheryl, I'm the VP of Ecosystem at CNCF, and you can find me on Twitter at OiCheryl. We also have the Cloud Native _LUN Twitter handle. So this is my opportunity to ask a little bit about you. So I'd like you to grab your phone or laptop or whatever and go to this link, oicheryl.com/p. And we're going to do a bit of live polling. So we'll find out a little bit about everybody who is attending this meeting. This will give you a service called Poll Everywhere. It looks like this. You can put your name in, just hit continue. You can skip if you want to be anonymous, but I'd love to find out a little bit about you. Okay, first question. Oh, this is not cleared. I think this is the answers from last time, but it's okay. We'll just add on from last time. So is this your first time at Cloud Native LUN? Please just hit yes or no. Looks like we are 75% no, 25% yes. If you missed that link, that oicheryl.com/p, you can also go to this longer URL. Looking like we're about 2/3 no now, 1/3 yes, first timers. Few votes still trickling in. And if you're on YouTube as well, then this is about 5 seconds live delayed from Zoom. So I'll just give you a moment so you can all make sure you get your votes in. Cool. I mean, welcome to everybody. Welcome to people who've been here before, and to the 30% of people who are new. I'm very glad to see you. Thank you for coming and joining Cloud Native London. Okay, we're going to go next question. Right, where are you right now? So I've got 3 options for you, which you can see on your screen. We have London on the top. We have England, or sorry, UK here. And then we have the rest of the world. So just tap on where you are, pick the closest or the most accurate for you. Still some people joining from the US, which is pretty exciting. Yeah, you can fix this. So if you landed in the middle of the ocean or something, you can fix it. This is awesome. It's really cool to see people joining from lots of different locations. I think this is one of the benefits of virtual meetups, that we can have people from all over the world. Well, I'll give a few more seconds, still a few people joining in. All right, I think we are slowing down now. Last chance. Okay, we're going forwards. Yeah, and apologize for the not clearing these results in advance. This is my bad. Okay, so what's your job title? Just pick the closest thing that you can see. Doesn't have to be exact. Your choice is architect, application developer, backend developer, engineering manager, SRE, DevOps, security engineer, or something else. And if you'd like to, please introduce yourself more properly in the chat or in the YouTube chat. Just say hello and say what you're doing. Cool. I think I saw most movement around like architect, SRE, DevOps. And if you're in other, I would love to like hear what you're doing. So please, again, just introduce yourself and say hello. Oh, still a few votes coming in. Cool, cool. All right, I think we have slowed down. So we're going to do something slightly different now. I've asked the speakers to submit some questions that they want to talk about. So I'm going to ask you these questions and then have Hubert, Pieter, and Prasenjit comment on the results as they come in. All right, let's go. Okay, are you familiar with Redis and have you used it in production in the last 12 months? So your choices are very familiar, use it regularly, familiar, use it occasionally, aware of it, but don't use it, or never heard of Redis before. So Pieter, I guess this one's really for you.
Yeah, this is interesting. So that makes me justify the structure of my presentation. I will talk first about what Redis is.
Yeah. Yeah, definitely. It's something that I think most people have heard of it. Actually, yeah, 8 people say they haven't heard of Redis at all. But I think most people have heard of Redis somewhere. All right. Okay, I think people have got the hang of this now, so we're going to move to the next question. I can move. Here we go. How much time do your developers spend on creating Docker containers, Kubernetes objects, CI/CD pipelines? I guess this is like, these are your application developers. So how much time do they spend doing SRE-like activities?
Right.
Prasenjit, do you have like anything that what were you expecting?
Yeah, my expectation from this survey was to see how much our developers or the real developers are struggling with in terms of understanding the Docker containers. How do you create an image? What are the fancy ways to create an image? how do you create those Kubernetes YAML files, and how do you deploy that? Do you really even care to do that? And yeah, that's basically that kind of a data that I wanted to have.
And is this kind of the spread that you expected? I see like a third of people say less than 10%. This should be a less than sign.
Okay. How much time? Yeah, I was expecting it to be a little more, but yeah, I mean, I can see that the numbers are growing. So yeah, let's look at that. I mean, more than 50% of the people are now 50% of the people as a developer are spending time to create those containers and those YAML files, and that's something that would like to take away from them, and put it in smart engine that should be doing it for them, rather than they just need to focus on their core business logic, rather than thinking about the pipelines, how do you run the CV scanning and things like that.
Got it. Cool, awesome, that makes sense. I look forward to hearing your talk about how you're solving this a little bit more. I think that is actually our last question. So apologies, we only have 2 questions this time for you, but thank you everyone for joining in with the live polling and telling me about you. It's awesome to hear that. So reminder for tonight's agenda, we're going to kick off with Pieter, who's going to talk to us about rediscovering Redis, or perhaps discovering for the first time for the 8% of people who've never heard of Redis before. Then Hubert's going to talk to us about how to not Kubernetes old habits in the container world. Then we're going to take a 15-minute break, and Prasenjit is going to finish us off with bring your code and not Kubernetes YAML. So if you have questions, please put them in the chat. We'll try and relay them to the speakers, but we're going to try and stick to this time. These times are in UK time. And then we're going to wrap up at 9 o'clock. Okay, thank you to all of our sponsors for tonight. I'd like to just invite them quickly to say a word or two. So do we have someone from Palo Alto Networks here?
Hi, Cheryl, it's Ashley here.
Oh, hey, Ashley, go for
Hi,
it.
so yeah, just very quickly then, Palo Alto Networks, we obviously do a lot of stuff with cybersecurity and big network firewalls and things like this. We actually love cloud native platforms as well. We use cloud native technologies ourselves, and we've developed a cloud native security platform to allow you to get on with the stuff that you need to do with actually making the people and the processes work to do with cloud native things, rather than worrying about the security tooling, because we can cover all the different capabilities. And that's really it. Hope we all have a great meetup tonight.
Awesome, thank you, Ashley. Kat, you are up for Technovo.
Perfect. Hi, everybody. I'm Kat. I'm head of marketing community at Technovo. Technovo is a challenger digital consultancy that provides expert partnership and growth without creating dependencies or disrupting culture. Communities are really at the heart of everything that we do, which is why we're really proud to sponsor Cloud Native, amongst others. So there are 2 ways in which you can find out more about me: either DM me on the Cloud Native Slack channel, or follow our LinkedIn page, where you can find out all about us. I also look after one of Technovo's community initiatives, which is called Meetup Mates. Meetup Mates is proudly partnered with Cloud Native London, and the idea behind us is simple. No one should feel that they can't go to a meetup simply because they have no one to go with. Given we're in very strange times at the moment, community is more important than ever. So our Slack channel is where like-minded devs can come together, discover the latest virtual events happening, and discuss what they've learned. You can find out more about us at meetup-mates.com, where you can also sign up. That's all from me. Thanks so much, Cheryl.
Cool, thank you, Kat. Okay, do we have someone from X Matters on the line? Okay, I think that Humio said that they can't send anyone tonight. We're going to go Red Hat. Okay, all right, so Pieter, you're going to talk about Redis, I guess, in your...
Yeah, I will, so like in a couple of minutes. But so yeah, Redis Labs is the company behind Redis. We do several things. So we do support the Redis open source product component. In addition, we create extensions extra developer capabilities on top of Redis. We also have a Redis Enterprise offering that can be installed effectively on-premise and as a managed service in the cloud. So that's what Redis Labs does. We currently are 400 employees, headquartered in Mountain View, and we just had a huge funding round. So we are now officially a unicorn.
Congrats, I think.
Well, to the founders, I'm involved. I'm not.
Awesome. All right, thank you so much. Thank you for all the companies who are supporting tonight's meetup and making sure we can keep going, keep gathering. All right, picture time. So this was something that we tried for the first time last time. We're going to try it again. Everyone, I would like you to turn your camera on if you have it off at the moment, and I'm going to try and get a selfie with all of us. So please turn your picture on. Okay, I'm going to do this old school style, okay, because I think this is more fun than taking a screenshot. We've got almost a full screen. We need 2 more people to join. Hold on, this is actually my kitchen. Okay, selfie. Selfie time. Okay, we have a full screen. Everybody smile, like wave, stick your hand up and wave. All right, sweet. Thank you so much. Thank you, everybody. Really good to see all your faces and say hello to people. And with that, I think I'm going to go back to sharing my screen. If you want to come and speak at Cloud Native London, then please go to this URL or cheryl.com/cloudnativelondon. We're booked up until I think May or June next year, so just plan ahead if you want to come and speak. And that is it. And don't forget to join the Slack channel as well. With that, Pieter, I'm going to hand over to you. Are you ready to share your screen?
I think
Awesome.
I am.
Looks good. You are up.
Thank you. So yeah, well, thanks for having me. So my name is Pieter Cailliau. I'm produced in Belgium, so that's why there's a funny accent. However, I do live or reside in the UK. I would say London, but most people can't understand when I say London. So I used to be a software engineer at TomTom, did something with the graphs, rolled into Neo4j as a consultant, came to the UK, and then afterwards switched to Redis Labs, first in sales, but now in product management. Unlike what Azam, the guy who effectively wrote my bio on the meetup site, I don't do yodeling, but I do like running, and you can find me on Twitter here. But this is not obviously about me. This is about Redis. So kind of like the structure of the talk today is to consist of 3 parts. So I will first talk about Redis core. So for those who are not familiar and who do need the 78% that do need a quick refresh of what Redis is, I'll talk about the modules. Effectively, those are the components that I'm product managing. And then we also have an enterprise tier. I don't want to spoil the talk too much about that, but it is kind of like the cloud native part of our Redis enterprise, or of the most cloud native part of Redis that we offer. I will touch only upon a couple of those topics at the bottom. So for those who are not familiar with Redis, it's a database. It's a NoSQL database, key value store. But more importantly, it's fast. It's extremely fast. And you've been using it all already. So it's in Twitter, Snapchat, Tinder, GitHub, Stack Overflow. So if you're not a geek and you are in the dating scene, you also have used it. So what are they using it for effectively? Twitter for their timeline. Every time you swipe, you will fetch an extra set of tweets. Twitter will make a backend call to Redis to get that effectively from, if I'm not mistaken, a sorted set. Snapchat for all the messages. Tinder for geo searches. So there's a geo data structure type within Redis. We'll touch upon these data structures in a bit. Then there is GitHub as a repository router, and then Stack Overflow for caching. There are many more use cases that I can talk about, but I won't do that today. I do want to say that it's also very popular, so most of you did hear or had heard about it. So it's the most launched Docker container. Speaking about cloud native, so 5.3 million a day. Those are numbers from 2019, and I think we already crossed that. It's the most used database in AWS, according to a report from Sumo Logic, and is the most loved database and the least hated, effectively. So Stack Overflow does a survey every year where they have a questionnaire with 150,000 engineers, if I'm not mistaken. And so it's the 4th year in a row that we're the most loved database. That also shows into the DB Engine rankings. So we're at place 7, but notice that we're the first key value store in that list. A bit about the community. So Redis is now 11 years old. Was created by originally by Salvatore Antiras. It's a bit of a legend. If you would like to follow him on Twitter, it's kind of like a proper rock star. The community is quite active. There are lots of client libraries in whatever language out there. Lots of Stack Overflow questions, GitHub stars that have been answered. But Salvatore effectively decided not so long ago, I think 2-3 months ago, to stop being the core maintainer of the project. So from me also, because I met with him a couple of times, I would like to thank him. So he decided to no longer be, I don't know if he officially got the title of a benevolent dictator for life, but let's assume he kind of like fits in that category, from my opinion at least. But there's a new light governance model in place, which consists out of Redis Labs employees, but also out of core contributors out of the industry. So we have somebody from Alibaba, we have some people from AWS that are effectively forming part of this core team. The Redis core product remains under the BSD3 license, and we're not going to change it at all. We do want to have our community very vibrant, and we want to strengthen this project release over release. And effectively, you could see that already. I think we did another release this week with some more bug fixes. So we also want to increase the cadence of releasing. So I hope you will see things there soon. So this is still all about the Redis core, right? So the Redis source, the Redis open source project. So if you would look at the Redis top differentiators, it's performance, simplicity, and extensibility. I'll talk briefly about those. So the speed, we can go over all the details there. So yeah, it's written in C. The core data set resides entirely in memory, and that's effectively already where it gets most of its speed. So no SQL database, so it threw away kind of like everything like locking, most authentication, all these things, they were kind of like thrown away, and it's also single-threaded. So single-threaded has some advantages. For example, if you have 5 operations you want to do, you can always do them sequentially because no other thread is going to interfere with that. But you might think that's a bottleneck, so you can't scale. We can effectively scale because we can shard your database by having multiple Redis processes. It also spoke about the O1 time complexity of most of the commands, but it also allows you to have a discrete access within objects. So if you would have the simplest of key value stores, and you would have, for example, a list, you would like to know the first element in a list, but you had modeled it as a string, you would have to fetch the entire string, have to deserialize it. With Redis, you can just say, hey, give me the first element of that list. So you can effectively minimize the data you're going to send over the wire. Those are some things in a nutshell. I'm sure you read all the other things while I was talking. The simplicity, kind of like the data structures. Once again, a simple key value story would just have a string. as a value, or what the value could represent in Redis. There are all these building blocks you could choose from. There are bitmaps, hashes, lists, sets, sorted sets, where you can order the elements. Then in extension, there's a geospatial index where you can effectively order points. There's some probabilistic data structures, the hype and log, and most recently to the family, there are streams. All of them sort of solve different use cases. The most common one you've known is strings for caching, for example. But you can use it, for example, to do recommendations if you would have several sets and you would like to intersect those sets to find tags or products that have tags in common. You could use it for that. You could use lists for queues. There's a PubSub, which is not on here, which you could use for messaging. Streams you could use for communication in between microservices, etc., etc. All of them are residing within memory, highly optimized data structures that you can leverage. So that is simplicity. So why is there extensibility? So Salvatore chose, got many requests on the repository, and lots of feature requests. Effectively, we're asking if he could add data structures for certain use cases. And he wants to keep the core of Redis as small as possible and as stable as possible. So what he did is he created a module API, pardon me. And in this module API, you can effectively create your own data structure and your own set of commands against those data structures. So you can write them in several languages, etc. The idea is you write your data structure, you write your commands, and then you plug it into Redis, and you get all the goodies from Redis. So you can you get all the client drivers that can connect to it. You get the high availability. You get the OSS cluster API to scale your database. All the goodies from Redis you get out of the box by just implementing your data structure and the operations you want to do against that. I'm trying to see if there are effectively there's a chat, but there is a chat, but when I went in presentation mode, it closed the chat. All right, so they can turn Redis into a true multi-model database. There are lots of definitions about multi-model databases. I'm not going to dig into this. For sure, what it does is you can have if you certain data structures could represent the database model, and if you can combine them in the same database, you effectively have a multi-model database, or the start of a multi-model database. But it's a direction we want to go into. So why Redis modules, right? So if you look at DB engines, once again, you can see there are trends in popularity in other types of databases. There is time series, which is lately going through the roof. Graph has been had a peak a couple of years ago. All of these data structures effectively don't exist within Redis. And what we did within Redis Labs when we started this module API is we did a hackathon. And we said to everybody, hey, you want to come up with some ideas for things we could do? And some of those resulted into products that we still support today. So I'm managing these 7 modules, and sometimes I do a presentation just with this with this image. But I try to categorize those modules into 4 dimensions. There's actually not that much to say about the axis. It's not a quadrant. It's just buckets, actually. So the simplest one I already explained, right? So you can just create your data structure, and you can add those commands on top of them. So that's effectively the bottom right quadrant. So we've got JSON, we've got time series, we've got Bloom. Bloom is a set of probabilistic data structures. Those are the simplest thing what it was designed for. But then we effectively also have index capabilities. In Graph, you could see as an indexing on top of your data search capabilities, Redis search, which I will talk about. You can also aggregate your data. So Gears is a programmable engine. I will come back to this, which effectively can aggregate your data, but can also add computing capabilities. And AI also, I will touch upon this a bit later on, effectively has some data structures, but also allows you to do to run your inferencing within Redis. So I'm going into the right-hand quadrant of my initial agenda slides. So talking a bit more about the modules. So the first one is Redis Search. So why did we create this? Well, we all love Redis, right? So if you do get for a user, which is then a simple string, which is a guessing use case, you will get the answer back. If you ask for all the fields within a hash, when this user key represents a hash, will return this to you. But when you know, give me all the users where the name or the first name contains Jeff, it won't give you that capability. So it's a key value store. It's a big dictionary, but effectively you can't do any full text search queries on top of it. So that effectively is what Redis search is. So we've built an inverted index on top of Redis. It allows you to do full text search queries, or also to have a secondary index engine on top of Redis. Nice thing about this is that effectively you will always read your own writes. You write something into Redis, and then effectively your index is reflected atomically. You can do data aggregation, kind of like if you would like to say, well, I have all this data index, you can do aggregation queries of that. On top of that, autocomplete and geo-indexing. Now, maybe I kind of like, just for full transparency, would like to add something about these modules and the Redis core and the Redis enterprise. So once again, the Redis open source is fully BSD3 licensed. The modules that are developed by Redis Labs, they are under the Redis source available license. So I'm not a lawyer, but effectively you can use them in your projects yourself as much as you want, as long as you there's more to it, but as long as you don't offer database as a service, you can do whatever you want to do with them. So they're extensions to Redis, and then effectively Redis Enterprise or Managed Services is a closed source product. So continuing this, right? So Redis Search is one of those modules. How does it look like? So here's a full text search example. It's kind of like Lucene query language. It's very close to it. So in this case, effectively, we will look for a country where that equals to Korea, engine that is either diesel or hybrid, and there's an SUV class. This is just how to show you how the syntaxing looks like. We also have an autocomplete capability with a try that is implemented. It's just a simple data structure, which can give you the same result as you are aware about. I can write this because I have a ginger beard, so I can use this specific one. Our aggregation effectively it's a pipeline where you kind of like have a group by and reducers. You can apply, you can sort data, etc. Nothing that should be too unfamiliar, but it's a different use case where either you search for a specific document or you kind of like want to aggregate a query across all your data. So Redis Search 2.0 is a large project we're working on right now, and it's coming soon, actually still this month. And although Redis Search is our most mature module, and we can talk about it for a while, but we're changing, or we're doing a huge change. By the way, it's been around for 5 years or 6 years, this specific module. The way you used to have to index data was effectively you would execute a command. So now you're familiar with Redis, you have commands. There was an ft-add command. You would write a document through the index, through the module, and then the module would effectively put that document within Redis as a document. We're going to change that entirely. So you're going to just use the vanilla core data structures of Redis. So you just do an H set, you put your document there, your hashes there, and then you create a schema. And you say, well, I want to index all the keys that start with a certain prefix, or where a field has a certain condition, and then you index that data into to your index. What's the benefit of it? It has many benefits. One of the things is that we took the index out of the key space, which was a bit dirty. But what we believe is that effectively there should be less steep learning curve, right? Because everybody who has been using Redis and has hashes in there and that would like to do some search query can just add the module on top of his existing Redis database, and then effectively create an index and start querying it. So there is no need to kind of repopulate your data. By the way, also all our modules are available on our free tier in our cloud offering. So if you want to go ahead and try this out, that's the easiest way. Redis Gears is a newer module to the product suite. So those who are familiar with Redis, they know that you can do some scripting, some server-side scripting with Lua, but Lua has some downsides, right? So Lua can't go across shards, so you can only execute a Lua script on a single shard, at least the Lua interpreter within Redis. There are a couple of other things that also are not that easily solvable with Redis. For example, you have pub/sub, but you don't have reliable key space notifications. So if you're not subscribed to a certain channel in pub/sub in Redis, you might lose that notification. And for that, effectively, we created Redis Gears. So Redis Gears is a programmable engine for Redis. It has a low-level C API with a full Python syntax on top of it. I'll show you some examples later on. It's agnostic from the topology underneath, so you can run the same scripts that you generate. You can run it on the Redis open source or the Redis open source cluster database, or if you use our managed services, you can use the same script everywhere. You can do several things, but kind of like two major things. You can do a map reduce pattern. So also this is the aggregate space I was talking about in the beginning. So you can aggregate your data, or you can also do the reliable event processing. And I'll talk about that a bit more. So here's just an example of a count for, let's assume that we have an IMDb database within our Redis. And in the hashes, there's a field called genres. And genre is a comma-separated list of the genres, and we would like to count how many movies we have per genre. It's a question you can't answer currently in Redis. You could do it with Lua, but only if you have a single shard Redis instance. Now with Redis Gears, you can. So effectively, it's kind of like a pipes and filter system. So you will create a map. You will execute the hget command. So the key only reader is going to fetch or stream all the keys within your database to the Python executor. It's going to execute the hget from that specific key. Is going to get the genres. When the field is not empty, is going to explode it by splitting your string on this comma-separated field, and then it's going to do count by. So it's quite clever that it's going to distribute parts of the work into each shard, and that is going to collect that back for you. So that's the map reduce type of use case. Another example is effectively you can also subscribe to key space notifications in general, but in this specific case, we're subscribing to a stream reader. So we're going to subscribe to all the messages that get into Redis streams object. And we're just going to increment the counter, which is called sum, by the number that is a field within each stream message. Just to give you a look of how this looks like, but we also have recipes with this. So we kind of like want to create like an app store of recipes that you can get. And the first recipe that we have is right behind. So right behind is a caching strategy, effectively. So you have a look aside, or you have read through or write through caching strategies. This specific one is a write behind. So you typically have your user is talking to your application server, and there's a database at the backend. And what you do effectively is you would like to place Redis in between for performance reasons. So you would have faster reads into your application. But with your writes still have to go through to your relational database or your backend database directly, which would give a different experience, because there are two things. Well, first of all, your application has to talk to two different databases, and you won't get the benefit. You will get fast reads, but you will still have slow writes. So this is just a pattern you can do with Redis Gears, and we did some small demo with this with the MySQL database and Redis. So the way this works, by the way, so forgot about the slides I have. So you effectively you write into Redis into a hash. There's a first function. So Redis Gears effectively talks to has functions. These scripts that I showed you are effectively functions. It will get a key space notification. You wrote something into a hash, and it's going to put the same data of that hash into a stream, a Redis stream object. And only when that is written, it will effectively reply to your application server. And then there's a second function that is going to do some asynchronous writing to your backend database. So it's going to batch, for example, it's going to take 50 messages from the stream, and it's going to write them to your backend database. So we did some tests here. So got on the left-hand side, so the Grafana dashboard, it will populate in a bit, but so these are the application requests with MySQL in the case of, so effectively the left-hand side, the MySQL is on the left-hand side of the Grafana dashboards, and the right behind is on the right-hand side of the Grafana dashboards. So with the right behind, application requests, by the way, all of them contain writes. We could see that we already can get a higher throughput in number of requests, single laptop. Now, what is more interesting is effectively if you go and look also at the database requests. So it used to be one-on-one when it was from your application server to your backend database. So the number of requests were effectively the same. Here, the yellow line in the MySQL case, there was no request to Redis. Effectively, we can see that this yellow line mimics the application request because each application request still has a write on top of Redis. What we can see effectively beautifully here is the write behind, right? So while Redis is processing, it can't do as many write behinds to your backend database. So you can see that while after our tests, which is just generating a spike of requests, Redis is still processing your writes into your backend database. Now, there are a couple of things that are interesting to observe, right? So you can make a joke about flatten the curve in this case because it effectively is kind of like flattening your writes here. But you can also see that we get to more requests on top of your MySQL database than were possible here. This is because we're going to batch your requests. We're going to take 50 updates and we're going to batch them into your backend database. So what's the benefit there is effectively you can reduce the resources that you need for your backend database. And still get a great performance. And the last thing that I want to show is effectively the latency. So this is a logarithmic scale. So what we can see, the red line is the 95 percentile, where we go from 32 milliseconds to less than I think it's 8 milliseconds. And effectively, I think the median is somewhere around 2 milliseconds, while it was here 8 milliseconds. So this is just a simple application, right? It depends, and it's all depending on your specific use case. But so you get a much more stable application by using Redis for both your reads and your writes in this specific case. So I spoke about Redis Search, about Redis Gears. I want to talk a bit about Redis AI. It's a bit of a newer module also to the family. And we do 3 things in Redis AI. So we add tensors as a data structure. So it's a multi-dimensional array. For those who are in the AI space, they will know what tensors are. The idea effectively is that you would have your data you want to send to your inferencing engine already in the data structure that you would like it to be. And next to that, we also have deep learning model execution engines for CPU and GPU. So those are all the common ones that you know. So we just created a wrapper around them. So you have TensorFlow, PyTorch, and Onyx runtime. And we can also do Torch script to create, for example, ensembles. And this is interesting because if you would like to create an ensemble as a data scientist or MLOps, you would like to create an ensemble that spans a PyTorch model and a TensorFlow model. You effectively can combine that from within Torch script. Torch script is it's kind of like a Python. It's a Python stripped down, I think, Python interpreter. I'm not too sure about that. That comes with PyTorch. So in the bigger story of AI, this is not something that we created. This is something that kind of like exists. So you start with a problem definition, you go to the entire training phase. Effectively, you need to get your model into production. So Redis AI kind of like only serves currently on the specific part where you want to push your model into production. So you can now, the model is a key within Redis, so you get the high availability. You can scale it over several shards. And the extra thing that you get effectively is data locality. So I don't have a good slide about this, and I regret now, but the simplest example is that is a chatbot demo, is a chatbot example. So in a chatbot, a model typically gets 2 inputs. The first one is your latest message that you want your chatbot to reply to, and the second input is the history of the conversation. As an output, you get a response, but you also get a new history of the conversation. So that new the history, the state of your specific conversation, you can effectively maintain that within Redis. So you can kind of create a session cache of those intermediate tensors. And that's why, because we saw that if you want to go into deploying AI into production, lots of time in the end-to-end inferencing goes into collecting that specific data. If you would put that set intermediate state back into a MySQL database, or not MySQL, but in whatever it is, another database that doesn't live with your inference engine, you're going to lose time fetching that data. For sure, the more time you need, the more data you need to create better inferencing, the more time you will lose with collecting that data. So yeah, we've got integrations with MLflow, Kubeflow. Spoke about the backends that we support. Last thing that we kind of like are trying to add is support for accuracy monitoring. So the idea is effectively that this entire life cycle is AI life cycle is quite a long process. I have 5 more minutes, right? 6 more minutes, 6 minutes. It's quite a long process where some data scientists start working on a project. They take some data which is their training data, and they think it's right. And after X amount of time, they publish it into production. Now, because that takes quite a long time, the world is changing. So the new things might have changed the behavior of your AI input and outputs. So effectively, you would like to track that. So you would like to, for example, say, hey, my model was trained for these type of input, and effectively it should have a certain range of outputs, and you would like to detect that as early on as possible, so you could go and initiate a new cycle as soon as possible. So we're adding support for that to do accuracy monitoring within Redis AI. And obviously, yeah, we work on CPU, GPU. We also have a Redis Edge Docker container that compiles entirely into ARM, so you can run it on your Raspberry Pi, etc. So that's the AI serving platform, but also we kind of like envision to add it kind of like in many of our other modules. So one of the things I would like to do is add the AI within Redis Search. You could kind of like increase the search relevancy by scoring, for example, your top 100 results by sending them once again to a model search results. Time series, which I didn't speak about yet, but could be used for anomaly detection and graph. There are many things, graph and AI start to be a big theme, where effectively you could, for example, use an ontology graph to create better or feed better information to your models. I have way too many slides, by the way, so I will skip a couple of them. But here's an example of how that looks like in Redis AI. Redis graph is a property graph. We're using adjacency matrices instead of adjacency lists. I'm not going to dig into the details, but if you're into that stuff, it's a unique graph project that gives some unique capabilities, because we can do matrix computations, and effectively we would try to do them on the GPU. A very interesting project to look at. Redis time series is interesting because, well, effectively it's just a simple data structure where you can model time series data. But what we recently created also for Redis time series, and then in general for Redis, which might be very relevant for you, is we created a Grafana Redis data source. So you can effectively query all the data that resides within Redis to do application monitoring. So it's not about the monitoring of how Redis behaves, but you can effectively look into the data that resides within Redis with that specific plugin. I don't have a link for it. We'll share it later on in the chat. Another example that we will share. Two things that we added. You can do out of order writes into Redis time series, and we have Gorilla compression. So because it's in a memory database, Gorilla compression, something with Facebook. It's about double delta encoding, all the fun. Effectively, we can go, a sample used to be 16 bytes, and now it's 2 bytes per sample. Long story short. Going to skip Redis JSON, another cool data structure, to the last part of my presentation, and I promise to keep it short, so I only have 3 minutes. So Redis Labs has been around now for a bit. So we've been managing Redis in production now for 7 years. We created over 1 million databases. We have X amount of data center failures, as you can read. So we kind of like have some lessons learned of managing Redis in the cloud. And I just want to say there that we have different incentives than cloud providers offering Redis. So for example, cloud provider, they make more profit if your instances are idle, right? The more idleness you have, the more instances you will have to pay for. On the other hand, what we are interested in is, for example, trying to get a higher margin on top of by better doing resource utilization, right? So we'll use those more effectively. So we effectively have a lot more knowledge about how we need to manage Redis and to try to manage it as in the most optimal way. And we can deliver this effectively in multiple ways. So we've got a cloud service, but we also partner with several cloud partners. So in Azure, Redis Enterprise is effectively the first party service, which will go in public preview, I think, in 1 or 2 months. We're also available on Google Cloud, and AWS is one of our largest partners because most of our databases are managed within AWS. And we also have support for Kubernetes, OpenShift, Rancher, Tanzu, which was the PCF, former PCF, and you can also run it on-prem. Now, there's one thing that I want to say about this is that so we have lots of these enterprise capabilities, and this is one of the things that I think is quite relevant and interesting for all of you. So what we did is we took Redis and we also implemented each data structure as a conflict-free replicated data type. Such we have an active solution with a consensus-free protocol. So why did we do that? Well, you have your data in memory, so it would be strange if you have a geo-distributed database that you would have to wait for an acknowledgement from another location that your write went through. That would just be strange, because why would you put it in memory in the first place? So with this CRDTs, effectively you will get local read and local write latencies, and there will be strong eventual consistency because there's a built-in conflict resolution. Can't talk much about these details. I think if you would Google CRDTs, it's not something that we invented. It's something academic that has been around for a while. What we try to do effectively is this is one thing of enterprise, and our modules, we also try to create active solutions that we can offer in our cloud specifically. And this can be done hybrid and on-prem, etc. So as I said before, we are a unicorn now. That means that we're above $1 billion valuation, and we had a nice funding round. And we're hiring. I'm particularly looking for product managers that want to help work on these modules. Thank you. This is the biggest proud of all the slides that is in the slide deck. For sure, it used to be like stars on the cheeks. But we have many other positions, right? So our R&D headquarters are in Tel Aviv, but we're effectively across the globe, also doing software development. We're an international team, and it's looking very promising for us. So we also have, if you want to learn more about Redis, we have a Redis University where you can take free courses, and you can also certify yourself into Redis. And I want to thank you. And if you have any additional questions, you can fire them to me or also to Azam, who has pinged me that his kids are quite noisy, so he might not be able to say anything. And that's it, I hope. 1 minute late, sorry, Charles.
No, awesome. Thank you so much for presenting this. This is great. I'm going to ask you to stop sharing your screen so that Hubert can take over. But if anybody has questions for Pieter, please put them in the chat. And Pieter, I guess you can stick around for a few minutes and answer any questions.
Yes, I will.
Perfect. Awesome. Thank you so much. Hubert, you are up next.
Yeah. Yes. You give me a second to share my screen.
Cool.
All right. Can you confirm that you can see it?
It looks good. It's all over to you.
All right. Thank you very much for let me talk with CNCF. It's my second time to be to be on this side of the conversation. It's amazing that even in our pandemic that this is still going. So we're very glad that we keep this fantastic community meeting here in London. So what I would like to talk with you today, it's basically so something as a part two from my last talk, but in the end is a standalone thing. How to not Kubernetes. It's basic. So let's start with who I'm working with. It's a company is called Suade Labs, which is, as you can see, founded in 2014, but we really started taking off in the last 3 years. So what we're doing, we provide a software solution to automate regulatory data requirements for financial institutions. Making more plain English, we're producing software for banks, multiple of them. And we have from our hands, we have a very specific set of requirements for what they have in terms of the security, in terms of how it's deployed, and in terms of what this software will do, and if they will work for the bank or not. Very specific niche, but Suade Lab it's doing very well, and I hope that they will continue and the journey to become really big company. So who am I to talk even to you guys? My name is Hubert. I'm from Poland, so this is my accent. I'm head of infrastructure in Suade Labs. So basically, I am main sysadmin, the person who is resolve the problems and make things happen, basically. So this is from where I come from. I was working in the hosting company in the past when I was answering phone calls and making tickets when the idea of the containers was introduced to me, and I was thinking that's very odd. We have packages to install the stuff. Why we need another kind of thing to install these packages? And the idea was somewhere in the back of my head until I heard about the Kubernetes. And then I understand one of the strengths of the containers, not only the easy as how they become popular, that you can create the software, but you will have a very simple way to deliver it, but also the idea that you can think about your data center, your computer, your whatever your case may be, little bit like a gigantic pool, not like a single machines. What is like this machine is doing only databases. So that was quite revolutionary. And since then, I move forward to the CNCF, and I become a big supporter for this idea. So that's about me. So let's talk about the two gentlemen, what they really influenced this talk. First one is Brian Lendluck. He for many years give a very awesome talk about the problems of the Linux, and but in the way that I really enjoyed that. For example, the best example what I first think come from my head when was the Wayland was introduced, and the Canonical decided, oh, in Ubuntu we will not use Wayland, we will produce MIA. And in the same way is a problem that we create another standard, but in the same way it is so democratic and so uplifting that we have open source solution that if I think I can do better, I can and introduce to the world. And if my solution is better, more people will be using. It is fantastic. So thanks to Brian Lendluck to help me to understand how to see the Linux containers and basically the IT world in the very lovely, but also very sometimes emotional way to. And of course, Casey Hightower, the big name of the Kubernetes, big advocate, I remember the first talks when I saw him, and since then every single one, it is just pleasure just to look at the guy and listen what he have to say. Even him, he makes the deploying Kubernetes so simple that you want to just sit in and just start doing that. So big shout out to these two gentlemen. So I would like to tell them, so as you can see, that Suade Labs is not producing software what you directly you can buy. That's more your money will be more interesting. But so I would like to take you on the journey about Robert, a young man who decides to right now jump into the system, not have a history of looking how the everything grow up, but a little bit what right now when he needs to start he decides to switch, he decides to move on, he decides to be sysadmin, he decides to be real DevOps person, and what he have a problem, what the challenges, what he have, because how he persuade the word when he needs to go in. But however, as much the ideas from you go for the landscape.cncf.io and you can see how many fantastic tools already are designed for Kubernetes. But the challenges what he been received to resolved, they are not quite there. There is not much talks what he needs to do. What he needs to resolve, and so he might be feeling a little bit alone. So I think that this is the first thing what we can talk about it. It's how to is a Kubernetes new distro, and I think that whoever, if you will be ever starting new project and you do not baked into any of the systems, you will have to you have idea. I will choose the Kubernetes, and here start to be a question. Kubernetes. So you want to use the cloud provider Kubernetes? So there will be AWS, there will be Google, Oracle, Linode, the companies, what they're doing hosting of the Kubernetes, physically hosting of the Kubernetes, it starts to be really, really big. And it's great. And it's really, empowering that Kubernetes become this kind of thing. But in the same way, if you do not want to use any kind of something what is host for you because you want to learn, you want to know how this works, you want to dive in, then you look for this list, and it's everything starts to get even more and more and more blurry, because as much as every single of this Kubernetes here named distributions have something specific to them, so they differentiate between each other. So if so all problems on the container world, we really reach to the level that whatever you want to create the software, you create the RPM package for Red Hat based distributions, and Debian for Debian based distributions, and you always have to have this tool to maintain it to support any Linux users. And this is actually coming back to, in this case, a little bit as well with Kubernetes distributions, because as much in the core they have a same API, but they start to differentiate in the details. That, for example, one cloud provider will provide you with this kind of storage what you can reuse, but other one doesn't. And is a differentiation? Yes. One cloud provider will be using one network solution, other cloud provider doesn't. With what you see right now on the screen, there is a list of the real distributions, what they can make self-distributing. If you want to have a few VMs, servers, or whatever case may be, you can deploy them on your machines, and you can play with it, but they will be never kind of a vanilla. They will so always make some sacrifices. Is that bad? No, because they can automate, or they can imply the knowledge, the what they learn with the time to the systems. And then, but if you are new to this and you want to learn the Kubernetes, you reach one of the big issue. For example, Rancher, it's really awesome UI who automate a lot of things. But if you want to have like a YAML file, what you want to deploy, it starts to be really, really tricky. And speaking, let's say Robert can speak from his from his experience that YAML files, what you can find on any GitHub, GitLab, or whatever case may be, whoever the developer provided this kind of things. Not you write it by yourself, but something from the developers. It's not translated very well. And this is actually, so you need to tweak your this YAML to your specific container distribution. Because this is what it is. We become so fragmented that this is new distro. Which one win the best? Or you think that the locomotive will be better for you? That's great. And the diversity is awesome. But in the same way, the promise of the Kubernetes was we will abstract. What the problem was on the first place. That you do not think about the infrastructure, but in the end, you have to think about the infrastructure, because these tiny things, what they do not always translate for AWS, will work on the Google Cloud. And so, if we, for example, be brave, we are brave. We want to go with I want to deploy Kubernetes in the really different way. I want to be I want to do everything by hand. That's great. There is very simple, easy way to deploy it with a Qt and DM. It is fantastic, very simple too. There is a kube spray, which is even better, because it's basically, let's take the kube ADM and write a lot of Ansible playbooks. So he's doing really big deployments with very simple way. But then it starts to get really funky. If I would like to see how many people deployed Prometheus without using operator, or the deployed only the Prometheus right now with the current state, how the Prometheus is, without using any templates, just the pure vanilla Prometheus. If you try to dig into this, it is really daunting, and the documentation in the Prometheus website, it is not that great to do this. So whatever I found, I found that the really awesome, the good people from now Red Hat, but then CoreOS, they create the operators, and fantastic. But then we're reaching to the second problem. API is new database, which is so you create the custom resources, the definition, and you can say this is my state and I want to be executed. And here's the funny part of when the Robert really hit the really something what is hard to understand. Think in this way: the simple deployment, what the Prometheus is, this operator and stuff like that is promising, will be to simplify everything. And it's true. But then you need a Grafana to deploy it. And Grafana, to have this nice and easy assimilation, they offer that that users, sources, and everything will be not stored in database like a Postgres. No. They decided to host everything in the Kubernetes API. So basically, when I tried to speak with the other people about why this is a thing, the best answer what they give me, it is just, API, it is stable. This is something this is something what like a really it's stick around. This will be something what will be running for really long. So there is much more resilient. So what is, if you translate this to English, it means don't trust the databases what you deployed inside the Kubernetes. Try on API. This is something not should be like that. And I reach these problems every single time wherever I find any kind of the very simple solution to, oh, this is quick and dirty installation. Yes, but if you don't want to do the quick and dirty, then it's just like snowballing. So if you not hosting only your application, it is start to be really redundant and time consuming just to have a simple thing like monitoring what's going on inside the Kubernetes. And if we don't, and let's say Robert don't have even time in this position to even start to looking for good logging solution, because that's another something what it's there. But as I spoke before, cloud agnostic, it is really great on the paper from the Kubernetes, but because every single cloud provider shaping the system to their needs, it starts to get really blurry. And hard to debug. Yes, the logging in the Kubernetes is really good, but if someone was trying to debug networking in the Kubernetes, he knows that this is a really funny story when the two containers can't communicate with each other, or which is better, when the packages are fragmented, because they should be like a jumbo size 9000, but what is receiving is they've been translated to standard size, so there is a fragmentation. So sometimes, for example, like the website was deployed, so everything load besides big files, and you have a timer on the big files. Why? Because the packages will slice it in the very incorrect way, and so your browser just decided to give up. Really, really something what it's very, very daunting. And don't get me wrong, I fully aware that Kubernetes is a framework. It is not a ready product, but it's a framework. But in the same way, this framework have a lot of questionable solutions. So here, what you can see, it's one of the tools what Robert found it. This is free to use it for everybody. This is the Elastic Stack, where they have a special module which you can deploy to the Kubernetes, which you have a very quick visualization what's going on in the whole cluster, which Grafana little bit lacking until you do this by yourself. Here is predefined, which is already very, very helpful. And I think that this is showing up. If there always is a question. It's 4 o'clock. Your phone is blasting that something is wrong. You need to find out as fast as possible to fix this so you can go back to sleep. Good visualization for the data, it is important. Never doubt that every tool. I love command line. I'm a Linux person. But in the same way, if I will have to set up every single Wi-Fi connection by hand by the command line, I will probably end up in the some kind of asylum, because this will be daunting. And so we create this abstraction layers to make our life easier. And right now, Prometheus, as much is fantastic, the way how right now the jump in to understand Prometheus, how it works, how he can extend, and for most funny part, how to force Prometheus to reach the machines what they are not inside the Kubernetes, it's really more funny, because the answer for that was, oh, you deployed another Prometheus with your config file, so you can. So I said, I have a 2. Why I have to have a 2? Why I can't have a 1? Why have a 2 what they HA, and so in this case I will have a 4. This is wasting. And that's, I think that this is the, again, old habits, our way of thinking come back to the Kubernetes. Kubernetes promises us to resolve some of the pains, but in the same way, we bring to the Kubernetes our old habits, because we do, for example, we do not think in the in the new way, or we would, or it is something what we never understand it, and we just decide, oh, it's just another deployment thing, another solution. So this is, besides of the have a nice visualization for the CPU usage and stuff like that, the Elastic also promising that really awesome integration with the logs, so you can straight away go to see the logs why this one container is using 100%. Security, that's something from last meetup was really nice, elevated, and I thank you. I can't explain more and more to the people to understand, when you design something for something, you should think the security should be in the when you designing. You should not be something what you're adding. So here's when you use OpenShift, is a Red Hat product. Really awesome Kubernetes distribution, but what they did is so the Kubernetes, as you can see on the screen, there is an option to opt into secure, opt in, not opt out, opt in. You have to say on the beginning of the deployment of the Kubernetes that you want security feature, which is excuse me.
I think someone just messed up the mute.
Oh, okay. So this was actually cool. So if someone was thinking about any security, he will think you should have security, which you opt out. This should be this way, not that way. So OpenShift was really awesome product, which is for free. I want to say for free. You can have fully fledged, not OpenShift, what is it called? OKD, but it is still really well documented Red Hat product, which it's fantastic. Which you can deploy it on the cloud, you can deploy it on your local data center, and will be work exactly the same. Which is just so promising, little bit more what the Kubernetes really was on the beginning. And I think that here you can see this is real thing. I was looking how to deploy OpenShift to the GitLab. Sorry, GitLab to OpenShift this way. And to deploy this to the Kubernetes, no problem. To deploy this to the Kubernetes with the do not run as a root, it starts to be really kind of funky. And as you can see, deployment to GitLab to OpenShift is problematic. And there is many differences, primarily to do with the security between the Kubernetes and OpenShift. I think that should say to you something about how hard is security. And so if you want to say that my application is secure, prove it that you run this on the OpenShift without giving any extra permissions about to access to the files or anything like that on top of the OpenShift. Then if you make this basic features, then you can say, oh yeah, this is secure, because it's time moving. This is my favorite. Rook, Paul Rook. I talk with the guys a lot, and this is the for example of the other thing about old habits come to the container work. There was a problem that Rook, if you deploy Rook from the operator, the operator could not even start when you're running not as a root. But if you deploy from the Helm, it could. Split brain problem. There was this. They make a mistake, and the operator have a little bit different YAML files than Helm. But it is still we coming back to the issue that somewhere in the they have a pipeline. They testing every single the changes what they do for the operators, and they do not catch that. So something is wrong with the designing of the pipeline. Something is wrong with the understand what we're doing. That this should not be catched by in the version 1.3. This is they say this production system. I was trying to deploy this in the production, really. And this is the first thing what I have when I try to use it sorry, there was the time when I was trying to deploy this to see how it works. I have this issue. this should not happen on the production. This should happen in beta. So what is the ending? The CNCF is fantastic, and Kubernetes been donated by Google to the Linux Foundation, and since then everything is thriving. But keep in mind that, you know, using big words, using that, whatever case may be, will not solve the old problems or old habits. Like whatever, I spoke with one developer of the software, what he was producing, and I find out that how he tests the software, he just using Minikube on his laptop. So he never tried his software on the real production. He always have a feedback from the people. So the deployment of his software to OpenShift was really fantastic, because, and I promise you that this is true, there was the script who was downloading the files to the temp folder and then executing and then changing permissions for the new files what was created. Think about a second, how, if you want to deploy any malware, what will be doing first? This is exactly path. But on the Docker, when he was designing this, was working. On the Minikube was working. And even if it was working, if you set up that you want to not run as root user, it was still working. But the lacking of the thinking that this is new world and there's new challenges, and there is already a good solution to keep you in check. It's a little bit less excuse, but I really hope for future, and I really hope that, you know, we are going in the right direction. And you know, thank you very much for having me and give you the talk. And if you have questions, please put them into chat or leave on the comment section down below. Hit the like, so you know we will have a nice amount of likes on this video. And thank you very much.
Thank you so much, Hubert. Did someone have a question? Someone was about to ask. Okay, I thought somebody had just unmuted, but feel free to speak up if you've got a question or a chat. Hubert, thank you so much. I love the fact that you're shilling for likes on this video, so it's not me doing it. Awesome. Thank you so much, everybody. Call to action. Yeah, good marketer. Okay, we're going to take a 15-minute break now. So we're going to go back to playing a little bit of music, but feel free to get up, stretch, get some water, chill out. We'll be back at 2:30 to start our third talk of the evening. Or feel free to come and chat with me as well, because I will be here drinking my cold brew.
I would have the lights on the timer, so that lighting pacing was not important.
Is the music. It's a random non-copyrighted music track from YouTube, because hopefully I will not have this video taken down by the YouTube monetization copyright thing. But I thought it was nice because we can pretend that we're having pizza together, just like old times.
Easy to move to the Kubernetes in the first place, and I still struggle to make this 100% working on the OpenShift. However, it's not about the security thing, but it's about that we use the very specific database which required to changes to the kernel. And OpenShift, that was one of the things what I found very interesting. They have a special tool which allows you to have some sort of modification to the kernel. In terms of, for example, if you ever deployed the Elasticsearch, you know that you have to make a changes to the kernel about how many files can be opened. This is one of the requirements, and how Elasticsearch did this. They have like a pre-starting containers what they do in this change. But in OpenShift, you don't have this luxury because it is not secure. And so one of the things what we're dealing with, it's a question is just like how the data is segregation. So if we have a requirement to that we will be provided the software, so they will be not deployed on the customer database, customer server room, but they will use any cloud provider. It's that we need to make sure that our software, for example, can be deployed not only in Kubernetes but also in the separate VMs. So we are in this kind of split that we have to request to deploy our application to Kubernetes, and we still have to maintain it that our application will be fully self-hosting system on this, like I say, single machines. And if you want to know how to achieve the good data segregation, it is Istio or Cailliau. The other case will be you will never achieve the level of the segregation, because this is the awesomeness of the Kubernetes, that they have built in the system, but you can say the containers, only the containers with these labels, they can speak with the containers with these labels. So you can have multiple databases, for example, for the clients, and with the good labels system, you can keep them completely segregated to the level that will be on the network level and unable to communicate. And that's my advice. Instead of running multiple Kubernetes, if you do not have to, if you, for example, your requirements is not that big, then of course we're having multiple Kubernetes. Why not? Why not have like a single machine Kubernetes and have the option to, for example, add another one to expand your application? But if you want to have only one Kubernetes, like I did last time, Cailliau, or Istio if there's only HTTP requests. I hope that this is answer your question.
Thank you, Hubert. I know a few people said the audio is a little bit loud, so it's a little bit hard to hear. My apologies, I'm going to break out OBS and figure this out for next time. It's kind of crazy with virtual meetups. It's like, you have to be your own AV technician, you have to it's a lot of stuff to handle.
I think that it's something what we could work actually is just go on YouTube or go on Twitch and ask the Twitch streamers, because they're doing this daily.
Right? Someone must know how to do this.
Yeah, and to be honest, there are, if you put good question into YouTube, you will find how to set up OBS in the way you would like to.
Yeah, I feel like Zoom should have a better control for this. Luke asked, he said, I was more concerned about separation on the control plane. I can't hear you very well though, so sorry if you touched on that. Did you talk about separation with control plane?
Everything that depends, because separation on the control lane, it's there is because I'm struggling with the answer, giving a good answer. It's because the regulation, because what we struggle with it, not only regulation from Europe but also from the world. So, and believe it or not, there is a few differences. And what the biggest question, I can't say too much, unfortunately, because I am obligated to not review anything was specific. So I need to be a little bit more vague. I would like to say there is a way to for example, achieve some sort of segmentation. This is the probably another something idea for another talk in this case. I will, because this will be so this is something what probably will require more than 5 minutes to explain it. So I don't want to take another time of someone else and take a wind, because we are here to share our journeys. And I hope that but if you have a good separation on the network, then everything else is much easier. If you can prove that the data is so separated on the network level, then everything is much easier, because in the end if you're scared, for example, if you're cloud providers, they have really good certifications, and we need to remember that if you like it or not, everything is going through the edge routers, so data always will be mixing. And is a good question about to keep the how tidy you need to get your system. My point is, it's again, I can't reveal too much, and so apologies. But I think that if you would like to, I can try prepare another talk, which we can discuss more approach to this level, how to keep the data completely separate on the nearly every single basis. And for the people calling me MC Hubert, thank you very much. I'm flattered.
Hubert has such a great voice with this lo-fi track. Really blends well. But definitely come back next year, I guess, when we have another speaking slot open, and we'd love to hear more from you, Hubert.
always a pleasure.
Likewise. Probably 2 more minutes till the end of our break. If you ever feel like leaving the SRE DevOps world, you could find a new career as like rap, spoken poetry.
You know, I would say that microphone makes a lot of difference, and I was, you know, most stuff wasn't we have our own internet radio, so I was popping up here and there. That's one of the fun of the memories of, you know, when you are a student and, you know, discovering new things, and the radio, like at this, you know, old-fashioned radio where you can put headphones, you know, listen to music, so someone interrupt from time to time, not with the commercials, but, you know, so something interesting to talk. That was really fun.
That's awesome. Like, no wonder you have like the right voice for radio. All right, thank you, everybody. We're back on with the last talk of this evening. Prasenjit, I'm going to hand over to you to share your screen.
Okay.
Kick off our third talk.
Should I start sharing my screen?
Please.
All right. So,
Hope everybody enjoyed our little momentary break.
yeah. Is this my...
Looks good.
This is good?
Yep. Yeah.
All right. Okay.
All over to you.
Thanks, Cheryl. Hi, guys. Good evening. So today my talk is about bring your code and not Kubernetes YAML. I am Prasenjit Sarkar, working with Oracle for about 4.5 years now, in a various different role as an outbound product manager. Then, you know, I have taken up a role of cloud native outbound product managers, and recently have taken up a role of a developer adoption and experience group, where, you know, I'm constantly reminding myself of, you know, what exactly are the problems that developers are facing today, in terms of the cloud adoption, in terms of how they can you know, focus on their own business logic rather than on you know, anything else. So when I say anything else, that means any amount of DevOps or SRE jobs or their responsibilities. So that is somewhere I'm trying to strike a balance where the developers should be looking at exactly on the code and the business logic and start developing on their code, rather than looking at how exactly should I code so that it can be integrated very well into when I'm going to upload it to the Kubernetes engine. Or for an example, how do I write something which is going to be put it into a Docker container, something like that. So that's just piece of things that I do. All right. So with this session, so what are the evolution of applications? Just hold on a minute. Let me just minimize this. Get it out of the way. Sorry. Yeah. So evolution of the application delivery. So what we have seen is that there are different elements in terms of the application delivery platform, and as you can see, the improvement that have helped organizations to deliver often and deliver fast. That means a faster go-to-market strategy, right? So what comes into our mind is that first thing first today is Kubernetes and microservices. And that is something that we are looking at right now. But Kubernetes for everything is not an answer. And Kubernetes for everyone is also not an answer, right? Now, let's look at the next one, which is, come on, yeah, which is the CI/CD pipelines. Now, with the CI/CD pipelines, obviously your developer are looking at how am I going to write an integration test? How am I going to write an unit test? How am I going to deploy this code? How am I going to run this in a pipeline? And then get into different stages of code deployment and do something with that deployment stages. And then finally get it to a delivery stage, right? So you need to look at those CI/CD pipelines as well. So that is something that we are tracking out today. And then, frequent code deployments. So, frequent code deployments is basically a strategy of, faster go-to-market and how am I going to solve the bugs that I'm hitting onto? How am I going to solve, the problems that I'm hitting onto into my product line? How am I going to deliver new product or new services for that matter? So that is something that we are looking at today, that through the frequent code deployments. But what happens during the deployment? So that is the operations challenge, right? Or the application operations. So with faster and continuous deployments, how do we operationalize our applications, right? So think about where you are just deploying a three-tier application, just about a three-tier applications, and think about an enormous amount of um, DevOps methodologies that you are going to integrate within that code deployment and then taking the things further, right? So think about that you have to containerize those three different codes or three different layers of the applications that you have developed, right? So, for example, which image are you going to take care of? Which base image that you're going to take off, right? How are you going to deploy? How are you going to create that Docker container? Is this going to be what kind of a runtime, container runtime that you think of when you are creating that Docker container, or even the container image, OCI container image, right? Think about how you are going to create security or vulnerability scan when you are just creating that Docker image, right? Think about what are the kind of environment variables and how do you create those environment variables within a Docker container, right? So you need to learn and practice all of them when you think about the application operations, right? This is not an easy job for a developer to focus on his own business logic at the same time think about all those resilience stuff, right? um, into the way of how you are going to deploy that code, right? So let's look at a three-tier architecture, a simple three-tier architecture. So think about what are the different stuff that you need to develop, right? So you need to think about a pod. We need to think about ingresses, a secret, a service, replica set, deployments, a daemon set, volume claim, a config map, volume, and stateful set, right? So let's look at all of them and think about this is just about one application, and so much for us as a developer to think about when we actually think about deploying the code itself, right? So all these YAML files that you have to create from the ground up to deploy your applications, right? So these are like, in my screen, I can see there are just about 10 different YAMLs that you need to create for just about one single pod. Think about a 3-tier applications, right? So when you do about a 3-tier application, this is just going to be multiplied, okay? And that is something that we are calling about op challenge at a scale. When why an organization, think about why an organization should look at this challenge now before you start on continuous scaling, right? So that is your lack of operational context, because you don't know what exactly is going to come to you when you actually think about how you are going to take this code and create those YAML files and then deploy that into your deploy it to your Kubernetes cluster. Forget about how you're going to maintain that Kubernetes cluster. Forget about how you're going to create that container image, where you're going to store those images. What about the backup operations of those registry images? What about a backup and disaster recovery, HA and disaster recovery and backup as well for about your Kubernetes cluster, right? So those are the operational context that we are lacking as a developer, right? So lack of operational context in here. So that is something that we are missing. Now, policy enforcement across the applications and objects becoming a really a challenging part right now. The next one is developers are having a hard time developing for Kubernetes. So if you're asking a developer to not only look at their business logic, not only look at their creating a testing strategy and test first strategy, and you are asking them to create a strategy for deploying it to Kubernetes first, it's a burden for them, right? It's a burden for them because they need to understand the context about how we are going to stitch all these YAML files, all these schema all together within a Kubernetes domain, right? So they need to think about how am I going to use a config map, how am I going to use a secret, how am I going to use volumes or volume claims, right? So they need to understand, they need to learn those technologies and then bind it all together and then start deploying it at the same time, thinking about how we are going to use them into their code itself, right? So for an example, if you're writing a code and then taking a variable from an environment, so then you can pass on that environment through either a Docker container variable, or if you want to do it in a fancy way, then creating a config map, or for an example, if it is a secret, let's say something, a sort of a token for authorization or something like that, you need to pass that on as a secret, and then you need to call that secret within your YAML file, within your deployment to decode that and pass that on as an environment variable so that your applications can decode it and then go it further, right? So those are the real hard time that these guys are facing right now. Now, platform operators have trouble managing these individual objects rather than the applications. So think about the platform operators who are actually creating that platform for the developers to deploy their code. They are handling these individual objects. When I say individual objects, that means those individual sigma of those Kubernetes objects. Like you talk about your volume claims, your volumes, your stateful states, your deployment states, your secrets, your ingresses, your security policies, and God forbid, if you introduce service mesh within that, then you need to think about a whole lot of other stuff, right? So this is something that the platform operators are right now handling. Now the fourth point is longer application support and recovery times, right? So this is basically the lack of application context that we are facing, or the organizations are facing right now, when they think about a faster go to market, when they think about a developer complexity. Okay, so 40, as per the survey, is like 47% of operations time and effort still spent on Kubernetes management, and this is a real life data. So this is something that we need to really be careful about. 47% of the time of operations time, right? And 53% of the time is actually on the development side. So if we are asking those for, if we can help those developers to cut down that 47% of the time to not to think about Kubernetes, not to think about Kubernetes deployment or objects or Docker containers, right? Or running a CI/CD operations or running a scanning operations onto their application code and also onto their container image, then those 47% of time they're going to be productive onto looking at how they can write a better code, how they can integrate it with other codes, with other platforms, and things like that, right? So developer experience and platforms is being impacted by Kubernetes right now. As I said, not everything can be used at a Kubernetes deployment site, and not everyone should be using Kubernetes. So you need to just create a kind of a scattered environment where the developers are completely separated from thinking about even Kubernetes does exist. It is just that, think about that, these guys are like 10 years back when Kubernetes was even not there. So you just need to write the small microservices and just forget about that. Let everybody else take care of that, right? Now, also, ops and SREs have little to no control and knowledge of those application dependencies and the history changes and the trends. So they don't look at the source code, but typically they look at the compiled code. So they don't know about those application dependencies. What are they depend on? How are they going to operate it? How are they going to see the trend, whether it's going to be CPU hogging or memory hogging, how much memory and CPU I should have into my node pool when I deploy this code, when I deploy these applications onto my Kubernetes cluster and things like that, right? So it's very hard for DevOps or SRE to understand even that what is my application requirement, right? Now, what we are introducing is a platform called Chiba. So Chiba is a control landing pad for your applications, right? So it is a control landing pad, as I call it as. Now, control landing pad, because you as a DevOps or as an SRE or platform operators for that matter have a say to how you control that application pad. So when you say, how am I going to control it? That means how you are going to control the application's deployment, how you are going to control the amount of resources being given to you when you actually deploy the code, how you are going to control that, how that code is going to be scanned, how the code is going to be converted into container, how that container is going to be scanned for CVE vulnerabilities, how that container is going to be converted into Kubernetes manifests, right? And then how it is going to be deployed, how it is going to be having a network security between the pods, how is it going to be, let's say, going through a CI/CD pipeline, right? So that is something that you are going to control it as a platform operator. And let's not bother the developers to think about even to convert anything on that platform, right? So let them just think about their code. So let's look at how does it work. So as a platform operator, as I said, you as a platform operator tend to create pools of resources. So when you say pools, it is nothing but a YAML file that I'm going to show you next, that is something that you need to create. And that YAML files basically is going to have a configurations, and that can include your security scan levels and exceptions. So for an example, you can create a security scan within that YAML file, and then define that how your code and your container, which is going to be built out of that code, is going to be scanned for security vulnerabilities, right? And if there are any known CVEs that you want to put it in an exception list and just move on, right? You can do that. What are the libraries and the language that the devs can use, right? So today with Cheetah platform, there are so many libraries and languages that you can support. So you have Go, you have Ruby, you have Python, you have Node, and all the other languages. So those libraries and languages you can use. Application consumption limits. Now, in a pool of resources, you create a resource, a kind of a resource segmentation where you are saying that you don't even need to bother think about that where exactly it is going to run. For an example, is it going to be backed by Google Kubernetes engine or an Oracle Kubernetes engine or an AKS platform? Or an EKS platform, right? You don't even need to think about which cloud platform, or is it a managed cloud platform, or is it going to be a vanilla Kubernetes platform, which is going to be backing this pool of resources, right? So that is where you create a consumption limits that from this Kubernetes, a managed Kubernetes engine or a vanilla Kubernetes engine, I'm going to create so and so resources. When you say resources, that means your CPU or your memory and storage, all things together, right? Team access. So let's say that based on the cost analysis, you can create a team access as well. You can give it a team access to certain pools and not to other pools and things like that. So you know, give it a team access of dev team access to only a dev pool, and a stage access to somebody else, to a platform, to the DevOps guys, and to a production pool to somebody who is going to deploy that to a production clusters, right? You can have services that can be bound to the applications, which is, let's say, your MongoDB or PostgreSQL. That means you, as a platform operator, create a service which can be consumed by your developers. So you can create that resources, which is going to be somewhere, let's say, some cloud provider. So they have, so Cheetah platform has supported various different public cloud providers, GCP, AWS, and Azure as of now. So these cloud providers are going to hold probably your on-premise. You're going to hold your MongoDB and Postgres and other databases, and you can have that service as an added benefit to that, right? Application auto scale. So Cheetah platform can do an application auto scale based on their intelligent logic, right? Storage volumes for persistence app. So you can create volumes and you can give that volume into the pool, and somebody who is basically nothing but your developer is going to consume that volume out of that pool into their code, right? And which Kubernetes clusters the applications can use. So it is also, as I said, it is also a kind of a segmentation where I'm not going to give away the details of where exactly it is going to run, right? Okay, so these pools are nothing but a YAML file. And if you look at this YAML file, you can see that I'm saying that with the pool name and the resources section. So it's basically a kind of a provisioner where exactly it's going to be provisioned. The plan name, the security scanning, whether the disable or enable. So it has a binary value, true or false. Scan the platform layers, which is also a binary value, either true or false. Then you can write down your ignore CVEs. So if you know any of them you want to ignore, you can put them there. You can create an access pattern for the teams. So you create a team, think about team as nothing but a group, and then you give that group to a resource, up to a pool resources, right? And then you can add the services that you have created, let's say an S3 bucket or a Kinesis or a DynamoDB, a MongoDB, or RabbitMQ, right? And then you give volumes. You create a volumes out of that. So you create a volumes of X, or provider, a capacity, an access mode, and then you give that. And then again, you can create an app quota, the number of applications that somebody can run on a particular pool, and so on and so forth, right? Now, Chiba had worked with the CI/CD, so they are fully integrated within the GitLab CI/CD platforms. So no changes are required on the development workflow. So it's gonna integrate with all major CI/CD platforms, okay? And developers no longer need to create any Kubernetes related objects. I mean, any Kubernetes related objects. So you bring in your own code, and using Chiba, you just say Chiba app deploy. When you say Chiba app deploy, once you run that, your code is going to be containerized. That means it is going to create a Docker container using an Ubuntu image as of now. So it's going to create that image. It is going to put up into the private Docker registry where you are going to run that Chiba instance. And I'm going to talk about that more. And then from there, you have your own Kubernetes cluster, which has been already added to the Chiba code engine. And then it is going to create those Kubernetes manifest. And it is going to pull that image from the private registry, and then it is going to push that into your Kubernetes engine and then make it up and running, right? So that is how the whole flow works. I'm going to show you that. So, it required the services such as DB, volumes, and others that can be consumed as services by those applications. It focused entirely on delivering the applications code rather than your Kubernetes and infrastructure related code. Okay, so think about this app X, and then it is going to be connected to a pool, and that under the pool, we are going to consume a Kubernetes cluster. I really don't care where exactly it is running on. I really only care about my applications, right? It can create an ingress. It can create multiple config maps, multiple services, multiple volumes. So basically, it is going to create objects based on the cluster, right? Different clusters have their different characteristics. So for example, a volume or a volume claim and a storage class in GKE looks different than an OK engine. So for example, in OK engine, the storage class is OCI, and in GKE, the storage class is standard. So those are something that you don't need to think about it, right? As a developer, all those things will be taken care of. Then obviously, as I'm saying that, it is a cluster agnostic and controlled change of state. Okay. And then obviously then your desired state is delivered. So Chiba platform is in the middle here, and then you can see that it can consume resources from the cloud infrastructure, which can be GCP, AWS, or Azure as of now, or managed Kubernetes services such as your AKs or EKs, or GKE or OK. And then you can use on-premises Kubernetes engine or VMware hypervisor, or even Microsoft Hyper-V as a hypervisor as well. So that is where your infrastructure operator sits in the middle, right? And then you come with your application development code. You can run it in various different ways. You can put it in GitLab, GitHub. You can run it with the CI/CD pipeline. You can run it with the Jenkins pipeline. And then basically that gets integrated with your Chiba engine, which is going to have your services, resources, security, traffic, scalability, and access platform, right? So that's all about the Chiba platform. Now, let's look at behind the scene. How exactly does it do, right? So this is basically the core services of Chiba. So it does have a load balancer and a cluster IP. So today you can deploy a Chiba core services platform using their own Helm chart into your own Kubernetes engine. So you can do that, but there are a certain amount of limitations if you do that onto your own cluster. And I'm going to talk about more onto their open source platforms, which is upcoming, and also their roadmap that they're working on. So basically, that is this Chiba service where you have this Chiba deployment, which is going to have encrypted connections between the load balancer, which is your ingresses, and your cluster IP, which is going to run your API, the image registry, your Guardian, DB, security scanner. Everything is all included within that cheaper deployment. Your routing and also the node metrics or the node monitoring metrics. So it's going to also hold the certificate secrets, your cheaper secrets, and the API config maps. So this is all about the cheaper core services platform. Now let's look at how exactly does it build the whole process. So this is the image building process. Now this is the left hand side is my cheaper core engine. Now it is going to have a connected cluster, and basically it so cheaper created this Kubernetes resources to run build kit on every connected cluster. The motivation behind using the build kit is to facilitate the support of different container runtimes, as well as have a single and transparent build process across the Docker and Kubernetes nodes. The application build process of Cheaper is broken down into different steps. So for example, the first step is to prepare the build context. Now the send the context and building the instructions to the build kit, then get the resulted image, and Cheaper API that inspects the image for vulnerability, and then the application's deployment with all the required objects automatically which is being created. So this is basically a flow which you can see that when you run Cheaper app deploy, this is going to be done, right, for you. So you don't need to think about creating a Docker container and a Kubernetes manifest and then deploy it and then run a scan on that, right? Everything is going to be done for you using this Cheaper.
Sorry to interrupt, just to know we've got about 2 minutes left.
Sure. So I have just 2 slides left. So can I deploy Cheaper, or is it open source? Yes. So you can deploy Cheaper using their Helm chart. I have this link in here. So you can go to Cheaper Corp, and using their Helm chart, you can deploy that onto your own Kubernetes cluster. They are going to open source some of their core platform engine soon, which is going to be in September 14th, what I have been told. Where do I do a deep dive of Cheaper platform? I have done that. I have written a blog about them. So you can go to this blog and learn various different moving parts of Cheaper and how exactly they're going to run that, and how you can containerize the whole code and deploy it. And the next one is the last thing, which is the roadmaps, right? So they are working on different roadmaps as of now. So until December 13, they have like 4 different roadmaps. So they're working on network policies defined at the pool and the app level. They're going to deliver the config file loading into their apps. And they're also, September 13 is where they're going to open source their deployment engine. They're also going to deploy. They're also going to open source their Cheaper services on November 13th. And there are a bunch of improvements which is coming up, right? All right, that's it for today. Thanks for having me.
Awesome, thank you so much. There were 2 questions about whether the product is from Oracle and whether it's cloud agnostic.
It is cloud agnostic. It is not a product from Oracle. It is a product by founder of Bruno Borges. Bruno Andrade. So Bruno has founded this company called Cheaper. So it is spelled as SHIPA .io. So you can just go ahead and look at that. So these are, they're going to, cloud agnostic.
Awesome.
Yes. So this is a cloud agnostic product.
All right. Thank you so much. I'd like to thank all of our speakers tonight. In fact, Hubert and Prasenjit and Pieter, thank you so much for speaking tonight. Thank you everybody for joining. We'll be back again on October 7th. So I will see you all there. Have a fantastic evening. Good night.
Good night.